I was actually curious about this thing, and one of the reasons that I was quite excited to actually talk to you about the API security space was the role of eBPF. And given that you have done a lot of work in that area, I wanted to understand how can we leverage eBPF when we are automating security for our APIs. Like this is not a straightforward, slightly complex technology even today. Not everybody is skilled in eBPF, but at what stage of automating API security for yourself as a team are you having the right kind of mindset or prerequisites to be able to move on to something like eBPF? What should be your use cases and things?
Yeah, it's a so I'll go back to the earlier point that we discussed, right? We started off saying like how do you solve API security at scale? We start with the discovery. And in my experience, eBPF's role is mainly in the discovery. So the
Okay.
uh, like we touched on, there are several environments, several clouds, and APIs are implemented in different languages, different frameworks. And discovering all of these, there are two ways to go. You could actually build a solution that is very, very specific to the API gateway that you are using, very specific to the language that you are using, like Java and Python could have a different solution. Or you could actually go with a solution that is completely agnostic to all these technologies and frameworks and cloud and all this. And that's where eBPF fills in. eBPF is a Linux kernel technology. It stands for Extended Berkeley Packet Filtering. I mean, for those who may not have heard about
Yeah,
it.
thanks for
Uh,
explaining that. Yeah.
yeah, so the beauty of this eBPF for this discovery is it's basically the lowest common denominator. As long as you are running your applications on a Linux server, it lets you look at the traffic. I mean, eBPF is used for networking, security, observability, several use cases.
Yeah, yeah.
But in the context of API security or API discovery specifically, you can use eBPF to tap into the traffic, HTTP traffic, or even RPC, gRPC kind of traffic. And because it taps in at that lowest common denominator, it is actually giving a single shot solution, irrespective of where you are running your APIs, how you are running, which language they are implemented in, all this. And even it allows you to get visibility into even TLS traffic as well, although it's like one more level complex to implement and get it working. But there are like a lot of examples out there in the web as well, in the BPF documentation and all of this. So you can easily go and look at them and get it basically. So that's the role. It's playing a huge role in API discovery at an unprecedented scale, that I would say. So you have like dozens of cloud accounts, multiple clouds you are using. You have your own data center, and your developers have implemented in five different languages and frameworks. And if he's your friend, is like there are other ways. Like again, the lowest common denominator is here is the network traffic, right? There are other ways to get network traffic as well. eBPF is not the only way. But eBPF, to your point, it's a complex technology, but kernel programming was very complex and even risky, error prone. You could even crash the kernel. What eBPF has done is like, made an average engineer to actually go and program the kernel. That's how I see it. So it is actually not as complex or as difficult as the previous versions of kernel programming. So it made it super easy. It gives you a safe sandboxed environment where you can actually go and do some of these use cases. So it's actually much easier. It has made it easier, not complex.
But so when you since we are talking about discovery itself, right? I understand that the more diverse your environment is, better it is to use something like eBPF. But apart from it helping with tech stack agnostic discovery, are there so at scale are there any other benefits, like particularly in terms of performance or
Right.
anything else that we get with this?
Yes, good that you asked. Tech stack is not the only advantage. Now let's go one more level deeper.
Okay.
I think it's rightly used, and this is where it gets little more complex use cases. The simpler use case, you install an eBPF filter and you get visibility into every API call. That's a
Okay.
lot simpler use case. Compared to packet capture technology, you can say this is one to one. Those are both are kind of similar. where you can actually take advantage of eBPF and take it to the next level, which is where we have done a lot of deep work, is you can be very smart. Let's take your application. Let's say it's doing like 1,000 calls per minute or even 100,000 calls per minute,
Okay.
and capturing that entire traffic and processing at that scale. It's almost like you need
Mm.
same compute as your original application, because your original application is
Yes.
processing all these calls and you are also processing all these calls, right?
Yes.
That is not practically possible. And you install this eBPF sensor on every machine, the resource requirement quickly adds up. And the same applies for packet capture, where eBPF is really flexible because you can program it. It's programmable, unlike packet capture, where you're just taking the dump and then you do whatever you want post capturing. You can actually push down some of this programmability into the kernel. So what we do is, uh, what you can technically do, you can say, hey, I'm not interested in so and so ports, so don't give me the traffic for these ports. I'm not interested in these IP addresses, so you don't even get the traffic coming from those IP addresses. So you can be very selective with your inclusion and
Oh,
exclusion list. And now you can have an eBPF sensor that is sitting on a machine. That machine might be getting million calls per minute, but
okay.
by selectively crafting the inclusion and exclusion list, you could only look at only 100 calls out of those million.
Oh,
That's the power it
okay.
has. But that's when, if you want to do things like this, then it definitely is a bit more involved and not for the faint-hearted.
Yeah, I think that's what I would say. But I think, given that it is possible to do that in a safe way, like you're saying today, many of us can actually think of doing that depending on what scale we want it at, and what is the requirement, and how selective we want to get, how much we want to customize, and how far we want to go with it. So, depending on the
This
use
this
case.
is this is one of my favorite topic, and I'm so excited because we get like a lot of interesting questions, and everybody comes up with this, right? Okay, now you are suggesting to do API discovery leveraging eBPF sensor or agents, and you're asking me to put this on every one of my machine. Like, do you even understand what you're asking me to do?
uh,
Right? First of all, you're asking me to install an agent on every machine, and
mm,
that resource wise, security wise, what security concerns I need to have, and how much resources I need to throw at it, and all this. And that's where, no, I am not suggesting you to put a simple plain eBPF sensor on every machine and look at every API call, because that is just practically not sustainable and your cloud bill could shoot up. What I am saying is, if you make the agent sophisticated and smart enough, it is practical without having any impact on your API calls. It's completely passive, it's completely out of band, and the resources can be kept very low. Like, even with very high volume servers, we could run eBPF sensor that takes only half a gig RAM and half core CPU. It's,
oh, okay.
so it's
Mm,
almost like an art, the fine like finely crafted art kind of thing. Like,
uh,
but if you tune your sensor like that, what it unlocks is almost magical. Because let's go back to that scenario, right, where machines are popping up randomly, applications are popping up randomly.
mm.
You don't know which one is exposed to the internet. Mushrooms are coming up. Basically, APIs are coming up like mushrooms. Now, this solution will still make you keep you in charge. You know every API that's coming up out there, and you can look at the data. You can look at the authentication mechanism. You can look at the permissions. All of that at scale automatically.
Yeah, I think if you know what you're doing, it might be one of the best tools in your kitty.
Exactly.
Yeah. Oh, okay. Interesting. So maybe we'll also keep that for, because this is quite an interesting area. Maybe I'll keep it, and itself needs a dedicated, episode. Maybe
Yes.
we'll keep that for a future episode, hopefully, if you do that with us.